Hello everybody, Mr. Rubo here. Today we are continuing with 310 trig equations and inequalities, and now we're going to get into some inequalities with these guys. So we looked at inequalities with polynomials and rationals, and we're going to do very similar ideas with trig functions. So here we have this basic sine function. This is like your standard sine of x, but with an amplitude change, right? But period is still 2 pi, but very standard graph here. It then tells us in this example, we're defined from negative 2 pi to 2 pi. So they're restricting our domain, and it wants us to find all values of x that where f of x is less than or equal to 0. Less than or equal to 0 graphically means under x-axis, right? So I look at this graph and I have this section here that is under the x-axis, and I have this section here. And remember, because of the restriction on the domain, this does not repeat. It's just these two sections, nothing else outside of what we see. So reading this graph, I would say, it starts going under at negative pi and stops at 0. And then it picks up again at pi and continues to be underneath the x-axis until 2 pi. And because it's or equal to, we include the x-intercepts just like we used to. And then because we have more than one part, we just put the union in between. All right, and there's our answer for this one, right? We could have given you this question before without even knowing these, without even knowing trig, with just knowing what you know from polynomial inequalities. And you should 100% be able to solve this, right? You just look under the x-axis. There we go. So let's go into some other ones. So it gets easier when we are given a graph, but we also have to know how to do it in the analytical form, or what we would call more algebraic form. For simpler inequalities that only involve one trig expression, we'll sketch the graph to help us determine the answer. So here, when we look at this, it says for what are the values of theta between 0 and 2 pi for which sine of theta is greater than or equal to root 2 over 2. So what we're going to do is we're going to think, where is sine of theta equal to root 2 over 2? Because if we know where it's equal to it, we then know, okay, well, we either, like those points where it's equal, it's either going to be between those 2 points or outside of those 2 points, right? And then we'll talk about it graphically. So if I solve this real quick, again, when I see root 2 over 2, I want to automatically switch it to 1 over root 2, because, right, I'm unrationalizing, because that's really nice for when I draw the triangle. So sine is positive here, and it's positive here. So the two angles that make this true would be pi fourths and, that doesn't look like a 4, 3 pi fourths. Okay, so there's our two thetas. So we either are going to say, okay, our answers are either between those two or outside of those two. Okay, and we can do this one of two ways. You can either substitute in points, substitute points in between those two, or we can just go for the graphic approach. So we're going to graph sine of theta, which we should know, right? Starts in the middle, goes up to 1, comes back down, and then goes here, and at this point is 2 pi, right? And that's all we care about, is 0 to 2 pi, right? They just want one period. Well, what you might not know is root 2 over 2 is less than 1, right? It's somewhere in between 0 and 1, but we know that these 2 points are when it equals it. So this point is pi fourths, and this point here is 3 pi fourths. So if I look at my quick sketch here, I want where the graph is above, like greater than or equal to, root 2 over 2. So I want this section of the graph, which how I would represent that is saying it's between pi fourths and 3 pi fourths. And again, because it's or equal to, we include the interval. All right, we include the endpoints, I should say. So there we go, and there's our answer. All right, and that's it for today. So thanks for watching. Have a good day.